Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students. So after completing the 4 problems on Laplace transform derivative, let's move ahead with the next problem. And in this, I'm gonna take the third order derivative term, and we are gonna find out the roots of differential equation by using the Laplace transform. So here we have to solve this y triple dash of t minus 3y double dash of t plus 3y dash of t minus y of t is equal to t square e to the power t. So guys, this is a differential equation. So y triple dash of t is nothing but the third order derivative of y of t. So it means the degree of this equation is 3. So we are going to find out the roots, not roots, but we are going to solve this differential equation, and we are going to find out the value of y in terms of t by using the Laplace transform. So let's start. So here I've shown you a few steps in the previous problem, so I'm gonna follow the same steps. So step number 1 says that we have to take the Laplace transform on both sides of that given differential equation. So guys, on the left hand side there are 4 terms. What I'll do is I'll take Laplace transform 4 terms separately, since there is plus or minus sign between the function, so I can apply the linearity property. So as per the linearity property, I'll take the Laplace of each and every term separately. So negative 3 outside. Now I'll take Laplace transform of y double dash of t. Now guys, after taking the Laplace on both sides, now we have to find out the value of each and every term. So to find out the value of this left hand side, I'm gonna use few formulae, that is the Laplace transform of derivative formulae. So guys, here there is a set of formulae. So I'll be using these formulas which are in blue color. So first one is Laplace transform of y triple dash of t. So this is given by s cube Laplace of y minus s square y of 0 minus s y dash of 0 minus y double dash of 0. So guys, I'll be using this formula, and I'm sure that you have seen my previous videos and you have revised this formula. So I'll be applying this formula directly in the given question. So here we will get, therefore so this is the value of first term, then minus 3. Then for the second term, again we will apply the formula. So here we will get now here we will get plus 3, and we'll apply the formula for this. So we'll get and then the last term, that is Laplace of y as it is. So Laplace transform of y equal to, now to get the Laplace transform of this function, here I'm going to use a property, that is the first shifting property. So guys, let's assume this as e to the power t into t square. So according to the first shifting property, the answer will be phi of s minus 1, since that is e to the power 1t. So guys, I'm sure that you have seen my videos on first shifting property, but then only you will understand how we are getting the answer. And guys, to get this value of phi of s minus 1 by first shifting property, we should have the value of phi of s. So here I'll write down, where this phi of s we will get by finding the Laplace transform of t square. So here the function is t square. So let's find it out on new page. Now guys, before proceeding, we will also put the values of y of 0, y dash of 0 and y double dash of 0, because these values are given in the question. So here this s cube Laplace of y will remain as it is. Here at y of 0 I'll put value as 1. So that will be negative s square. Here it is 1. So negative s, and here it is minus 2. So positive 2. So let's see what we get. Guys, after this, here this bracket is being multiplied by minus 3. So first term will be minus 3 s square Laplace of y. Then minus 3 into minus s, that is plus 3s into y of 0. Y of 0 is 1, so that will be 3s. So positive 3s. Next, y dash of 0 is 1, so that is minus 1. Minus 1 into minus 3 is plus 3, so plus 3. Here we will get 3s Laplace of y. Next, the value of y of 0 is 1, so negative 1 into plus 3 is negative 3. Next, minus Laplace of y is equal to, now we have to find out the value of function of s minus 1. So to get the function of s minus 1, we should get the value of function of s, which is the Laplace transform of this t square. Now Laplace of t square, here I write down, it is 2 factorial, which is 2 upon s cube. Now guys, in this I'll put s as s minus 1. So 2 upon s minus 1 the whole cube. Now guys, let's take all Laplace of y terms together. So we'll get, therefore, s cube minus 3s square plus 3s, and here minus 1 into Laplace of y. Next, let's take the remaining terms together. So negative s square, that is the only term, so here I'll write down plus in the bracket minus s square. Minus s and plus 3s will become plus 2s. Then plus 3, plus 2 plus 3, 5. Then minus 3, that is plus 2. And on the right hand side we'll get this term, which is 2 upon s minus 1 cube. Now if you see this bracket, then it reminds me about one formula, and that is nothing but the s minus 1 the whole cube. So these 4 terms are the expansion of this formula. So into Laplace of y. Now here I'll take these terms on the right hand side. So we will get 2 upon s minus 1 the whole cube. This will be plus s square. This will become negative 2s, and this will become negative 2. And then we will take this term, that is s minus 1 whole cube, on the right hand side. So we will get Laplace of y equal to 2 upon s minus 1 raised to 6, because already we have s minus 1 cube into s minus 1 cube, s minus 1 raised to 6, plus s square minus 2s minus 2 upon s minus 1 the whole cube. And now guys, we have to find out the value of this y in terms of t, and for that I'll be sending this L on the RHS, so that will become Laplace inverse. So guys, it means y is equal to Laplace inverse of this given function, which is 2 upon s minus 1 raised to 6, plus here in the denominator s minus 1 cube, and numerator is s square, and value of this will be a function of t, and that function of t is nothing but value of y, and which is our final answer. Now guys, the question is how to get that function of t. So here for the first term, getting the inverse Laplace transform is easier because here I can apply the shifting theorem. But guys, what I'll do is in the second term I'll be bringing that s minus 1 term also, so that in the whole function I can apply the shifting theorem. So here also I have s minus 1, here I have s minus 1. Now let's bring s minus 1 in the numerator, and for that we'll do the adjustment. So here I'll write down this minus 2 as plus 1 minus 3. So here I'll get now guys, here plus 1 minus 3 is gonna give me minus 2, which was the original term, and remaining things I've kept it as it is. Now this bracket, if you'll observe, then it is the expansion of s minus 1 the whole square. So here I'll write down that term. And now guys, if you see this function, then it has got converted into function of s minus 1. So here I'll write down this has become function of s minus 1. And whenever we want to find out the inverse Laplace transform of this function of s minus a, then we find it out by using the shifting theorem. So I'll write down that shifting theorem for you. So L inverse of function of s minus a is given by e to the power at into L inverse of that function of s. So guys, here we have this function of s minus 1. So I'll use this property. So we will get y equal to e to the power, now value of a is 1, so 1t, that is t, and we are going to find out Laplace inverse of 2 upon s to the power 6, because we have to find out inverse Laplace transform of phi of s as per the property. So we get this by replacing s minus a with s. So here s minus 1 will be replaced by s, so we will get s raised to 6. Here we will get plus s square minus 3 upon s cube. Now here I'll divide these two terms separately by s cube, so we will get e to the power t L inverse of 2 upon s raised to 6 plus s square upon s cube is 1 upon s minus 3 upon s cube. So now we just have to find out the inverse Laplace transform of each term separately. So let's start. So here e to the power t as it is, and in the bracket I will find out the inverse Laplace transform of each and every term. Now guys, this 2 is a constant, I am taking it outside. Now what is inverse Laplace transform 1 upon s raised to 6? So it is t raised to 5 upon 5 factorial. Then inverse Laplace transform of 1 upon s is 1. Next, negative 3 constant outside, and inverse Laplace transform of 1 upon s cube is t square upon 2 factorial. So guys, we can rearrange these terms. So e to the power t will remain as it is. Here this will become 2 upon 120, or you can say t raised to 5 by 60. So then here 2 factorial is 2. So I'll say negative 3 t square upon 2, and this plus 1 as it is. And guys, this is nothing but a function of t, and here we got the value of y in terms of t. So it means we got the solution for this differential equation. So here I've solved this differential equation by using the concept of Laplace transform and the inverse Laplace transform, and I'm sure that you understood the explanation and you will be applying the same concept in the examination to get the good marks. So keep watching the videos to learn more about the engineering mathematics and ekeeda.com other subjects. Thank you very much.